Hello and welcome to Web Math Academy, where today we're going to discuss an introduction into the use of complex numbers. What are complex numbers? Also called imaginary numbers, complex numbers are assigned the letter I equals the square root of -1. Now, since no number times itself equals a negative number, I is used to represent this value instead. There are many applications for such numbers, such as in the field of electronics. We'll explore these avenues later. For now, let's look at the arithmetic rules for handling two complex numbers. They consist of a real part and an imaginary part as follows. For complex number 1, we use the coefficients a plus bi, and this would be, as an example, 3 plus 4i, which equals 3 plus 4 times the square root of -1. For a second complex number, let's use the coefficients c and d. As an example, we can use 5 minus 2i, which actually equals 5 minus 2 times the square root of -1. Now, what we would like to know is how to add or subtract, multiply, or divide complex numbers. Well, it's actually not as hard as you might think. You simply hold the real part and the imaginary part separately and multiply their coefficients together, or gathering like terms. For example, to add a plus bi plus the complex number c plus di, we just gather the a and the c for the real part and gather the b and the d for the complex part, the imaginary part. And you do the same thing with subtraction and multiplication. Now, division of complex numbers is a little more involved, and it takes the multiplying of the denominator and the numerator by the conjugate, which in this case is c minus di. By doing this, we get rid of the terms cdi and negative cdi, which cancel each other out, and we're left with c squared plus d squared in the denominator. And then we gather all the like terms in the numerator, ac plus bd plus bc minus adi. And we have an example of that here. We're going to use the complex numbers that we looked at up here as an example. 3 plus 4i divided by 5 minus 2i, and that equals, if we multiply the top and the bottom by the conjugate, 5 plus 2i, that gives us in the denominator 5 squared plus c squared, which is negative, or d squared, which is minus 2 squared. And in the numerator, we have all those terms that we gathered up. And if we multiply these together and add, we get the answer is 7 plus 26i over 29. And that equals 7/29 plus 26/29i. And that's our answer for division. Now, this is very instructive and shows us exactly how complex numbers are put together, but why go through all that work when we can use our TI-Nspire graphing calculator on the left? So we're going to go through this same division example, and we're going to plug it into the calculator. So first, using left parentheses, then 3 plus 4, and then for I, for the imaginary number, we go to the pi sign down here, click on that, and you'll see it gives us a number of different mathematical operators here. We're going to just pick the I. Then right parentheses, divide, left parentheses again, and this will be 5 minus 2i. And you might be tempted to just use the I that's in the alphabet here, but that isn't actually considered to be an imaginary number for the calculator. It'll just change it. It'll treat it as a variable. So you really have to go to the pi sign and click on the I here. Right parentheses, and enter. And there it is, just like what we have down here, 7/29 plus 26/29i, and that took seconds. So we hope you've found this tutorial useful, and we'll be talking to you next time about polar coordinates in the use of complex numbers, which is even easier for multiplication and division.